This is great. This is going to be like a nice personal talk, like more like a little fireside thing. Cool. So my name is Parker McCurley. I run a company called Decent. We're a consulting services firm that builds software for blockchain startups. Basically, I've spent the past year working full time in the space, building a lot of different types of decentralized applications. And I wanted to share a few lessons that I've learned from that experience here today. So is anybody here a software developer? Could I get like a hand raise?
By choice or by?
Having to pay the bills. All right, cool. So I'll try to keep things like more geared towards, high level versus, down in the weeds. So so first thing I want to talk about is what my personal goals are for blockchain technology, because that's the context by which I would like to frame the rest of this talk. So goal number one, like most importantly, is mass adoption by our global population, right? This is like everything from people discussing how, enterprise corporations can use blockchain technology for supply chain and logistics problems, as well as the quintessential, when can I buy a cup of coffee with my Bitcoin, right? But at the end of the day, that's what we're all looking for. That's what benefits everybody who's currently in the space. And that requires, mass adoption by large corporations, right? So we need blockchain technology not first in my opinion, not first in the hands of the consumer, but first in the hands of, legitimate businesses that are producing value using the technology, improving existing business problems. And the biggest issue thus far that's been preventing that is blockchain technology at scale, which obviously everybody talks about quite frequently. Today, I'm not going to focus as much on scaling options for blockchain systems. I'm going to focus more on how we can use blockchain technology as it exists today in a scalable fashion. But yeah, until the day comes that, we can produce software using existing blockchain technology that can scale out the way that a traditional web application can, there's going to be a very big limitation on, what we're capable of doing as an industry and how seriously the technology is taken by, decision makers at large corporations, beyond the interest in research and development and proof of concepts. So here are the big problems, right? So today, existing blockchains cannot function at that scale. I remember when I kind of first embarked on this journey, there was this whole idea of decentralizing everything. Take all the existing systems that are, run by the governments and the evil corporations and burn them all down and replace them with peer-to-peer systems. And the technology just doesn't support that. Not today, at least, and certainly not back then. It's gotten plenty better. But, that was the mentality of myself and I think a lot of other people at that point in time. And we've seen a lot of different attempted solutions to solve that problem. The biggest one that I've heard the most about over the past year is the concept of a private permissioned blockchain, which for those who aren't super familiar is essentially like classical distributed database that shares some of the cryptographic elements of a real blockchain such as Bitcoin or Ethereum, typically linking sets of data or pieces of data together over time. So here's my personal controversy. So I personally believe that calling private distributed databases blockchains is almost near predatory. I think that a lot of people who don't have a complete technical understanding of how more classical blockchain systems work are pretty easily sold this perfect technologies that are highly scalable and millions of transactions per second and blah 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 and all the things that kind of the core technologies that our ecosystem was built on are not capable of doing, which is a huge concern of mine. If you look at technology over the years, let's take the internet, for example. The internet was this amazing tool to break status quo and allow information to be shared freely. And especially if we look at the past year, but really a long time ago, we gave up control of the internet to cable companies and other technical infrastructure, and now we're getting to the point where we're seeing high tech companies on the news every day due to essentially fraudulent business activity. every cable provider that I'm aware of in the United States records all of their users' browsing activity. And it's become the norm rather than a tinfoil hat solution to use systems like VPNs to, protect yourself online, which is crazy because the internet literally was the greatest opportunity that an individual had to, take a little bit more control over their lives. I'm very concerned that blockchain through misinformation can be turned into the same thing. So in my vocabulary, I'm going to read straight off here. A blockchain is an open system designed in the spirit of Bitcoin that allows any and all people to participate as a node operator without any inherent system of control or hierarchy. Meaning, in Bitcoin, if you want to be a miner, you can be a miner. If you want to run a full node, you can run a full node. Same goes for Ethereum. There is no other organized structure preventing anybody from entering that system and acting as essentially an independent auditor of it. To me, that is the fundamental principle that all this security that blockchains can tout comes from. So that's super depressing, obviously. And a few examples of where I've seen this play out in the space. My first kind of encounter with not being able to create production software due to blockchain limitations was with an ad tech company I spoke with in New York City. So in the world of advertising online, there's a concept called an impression, right? Which might be somebody seeing a banner ad on a website. A single impression is very low value. The business model in advertising digitally typically relies a lot on high volume and exposure to a lot of consumers. So the issue there in their desire to build essentially a peer-to-peer advertising platform is that if an impression costs, or is worth $0.000001 US, and a transaction to pay an advertiser from a peer costs $1, obviously that's economically infeasible. So I think around the same time, a lot of other people were running into those issues, and this word started getting thrown around called microtransactions, which is, this idea that cryptocurrencies are inherently pretty poor at transmitting high volume, low quantities of money. And the fundamental thing that I always try to bring it back to is if the cost of the transaction exceeds the value of the service, be that sending somebody a penny or transmitting or storing some piece of data, then that is a software service that cannot be built directly on a blockchain. There's also technical failures. So, blockchains are inherently imperfect. I'm not going to dive 100% into that, but they were not designed the way that, for example, a server-side web application is designed to scale and operate performantly. Blockchains, to be secure and to be stable, require a very different set of rules and a very different set of objectives. I frequently find myself having conversations where I explain to somebody why Bitcoin is slow on purpose, right? For fault tolerance. Storage, also inherently problematic. It's really simple. If we're storing everything on a ledger, such as in an array in a smart contract, storing something once on a server, cheap. Storing something many times, very expensive. Very secure, but very expensive. And finally, we have the latency. So due to things like block times and inherent failures as a blockchain grows over time, stuff like requiring high volume, real-time data transfer is very, very, very difficult to pull off on a blockchain environment. And ultimately, security failures can occur, which is what I view any blockchain that allows any participant to have administrative or pseudo access or the ability to overwrite records or essentially an undo button, in my mind, is no longer a valid blockchain. Those are systems that I'm sure provide plenty of other values. However, they do not retain the kind of closed, vacuumed, secure qualities of a traditional blockchain. So here's some good stuff, right? As far as proper production blockchain software that we've worked on in the past year. So the first case study I want to talk about is Kairos. They had an existing product and were interested in selling to a new market, being the cryptocurrency and blockchain space. Their product was essentially a artificial intelligence powered facial recognition software. And the way that they sold it was behind an API gateway, similar to what Twilio does for SMS or what Stripe does for credit card transactions. So basically, if you had an application where you wanted to be able to, use face for authentication or some other means of identifying, you could, rather than roll your own computer vision software, you could use Kairos's and send images to their API and receive information. So they're really interested in moving into this blockchain ecosystem and being able to sell that product to smart contract developers, dApp developers, and of course access this new token economy. And basically the initial issue is we're talking about software that is very compute heavy. Facial recognition, like image processing, these are all very compute heavy processes that should not be done on a blockchain due to the inherent limitations in these systems. So the way that we ended up approaching this, we built what we would call an Oracle wrapper around their API, specifically to sign transactions back from the API. And we built a smart contract interface to allow Ethereum developers to access this facial recognition software in a format that played nicely with a decentralized application. So basically what we kind of determined was, how do we draw the line of trust, right? Walking into a room as like huge blockchain enthusiast, huge fan of Bitcoin and the original philosophies there, huge fan of Ethereum. Where do we draw the line of trust and say, we can't implement this in that fashion? So the thought process led me to this. If I'm sending an image to their API, right, and I'm expecting a result back of recognize face, don't recognize face, I'm already trusting this company to do their job right. And in fact, in our economy, a company must and is heavily incentivized to do their job right and provide a service so that they can stay in business. So in that way, it didn't really affect anything if the facial recognition itself occurred on a blockchain or in a smart contract, which isn't possible today, because I'm already placing this trust that they're going to provide that service correctly. Otherwise, it's useless. So we focused on the communication pipeline between the blockchain and the Kairos API, essentially ensured it, and we were able to produce this smart contract interface that closely resembles a SDK in a traditional programming environment to allow them to start selling to this whole new market, right? At the time, and as far as I know today, it was the first implementation of facial recognition software or biometric software of any kind that you could play with in the Ethereum developing environment. So, the end result was an existing product that can sell to a brand new market. Now here's an inverted case study. This is actually a local company in Austin called Switch, and they are a new product for an old market, the energy industry. Switch was founded by a majority of folks from the energy industry who wanted to use, future technologies to improve the ability of businesses that produce renewable energy to receive subsidies from governments like the German government. So I'm not an energy industry expert, but as far as I understand, in Europe, there are government systems where if you're producing green energy or stopping the production of non-renewable energy, you can receive a tax credit, colloquially referred to as a carbon credit. So they had a very big idea, right? We want to use this. There's this very fraudulent, ecosystem, which is essentially any regulation, right? And we want to use technology to remove the auditor, to remove the physical hand-holding and processes here, and have a fraud-proof business model. So this required like a very wide array of existing technologies, from IoT sensors at production sites to artificial intelligence software to validate the production data and add an extra level of security there. And most importantly, this is like a very widespread distributed application that requires a lot of fast-moving data. None of these things are good for blockchain, right? However, the chain of custody of data from one party to the next, that was a, amazing use case for a blockchain. And it's essentially what it's designed for. So what we ended up doing was we looked at their kind of whole landscape, right? With the end result being we need to verify that this data is legit and then use it to distribute these carbon credits tokenized through our system, right? We were able to identify essentially where chain of custody changed from energy manufacturers to auditors to credit awarders, and essentially, record that data at scale into a public blockchain, Ethereum. So that was a project that was very interesting because, again, we have to identify where do we draw that line of trust? Where do we say, okay, we have to use this technology today, not 10 years from now. How can I harness value from it that is unique strictly to blockchain systems, and provide real value there? So this was a really awesome example to me. And it leads me to this concept that versus day one developing blockchain software, which was a militant approach of how do we burn it all down and replace it with decentralized systems, now I say the decentralized systems that we've produced, such as Ethereum, are very valuable. How do I look at the stack as an application architect and say, if we have APIs, databases, message queues, all of these little tools that we have in our tool belt to produce scalable software, where do smart contracts fit in that picture? Rather than how do we remove that picture and replace it with, native blockchain software? So what's the point of this talk? Basically, the agenda that I'm pushing is that it is no longer valuable to the entire ecosystem to have a sole purpose of focus on decentralizing entire systems and scaling existing blockchains to, closely resemble what we can do on AWS with web applications today. I think that right now, obviously, there are much more brilliant computer scientists than myself who are doing those things, and it's wonderful. And working with a system like Ethereum over the past couple of years, we have all seen it grow and scale and get better. But today, there is still value that can be gathered from blockchain systems and should be gathered. There's applications that we can build that we've never been able to. We have the ability to enforce trust and enforce essentially accountability and good behavior in software for the first time. And I think that now is a very important time in history to recognize this, as we see companies like Facebook, right, who are being, caught by our government lying to users, lying to customers, because there's no way to hold these systems accountable. They've grown extremely powerful. With blockchain technology, we have the ability to embed trust, or as we like to say, trustlessness, in these services and allow existing technology to carry similar characteristics to a cryptocurrency. And so I'd like to announce now, in 72 hours, we're launching Topaz. It's our new product company. And the goal of Topaz is essentially to provide developer tools for businesses that allow scalable access to value propositions of blockchains. Our first product is data-centric. It uses, through SDKs and simple APIs, the ability to, at scale, attest the state of data in any blockchain over time. So rather than, strife about, I have 1 million transactions per day, how do we store this in a secure fashion on a blockchain? We've built software that is a layer above that can take that 1 million transactions and economically and performantly, isolate those using cryptography and prove that they existed at a certain point in time, which is the immutable ledger that businesses have found so much value in. Verticals like compliance, regulation, and supply chain that we've read articles about all year can start using this software today to access these value propositions that have been listed in, Forbes, Wired. These are all the things that we discuss, right? These are all the things that we're looking forward to in 5 to 10 years. And I think that today, by using a combination of existing technologies and these new crazy ones that we've been playing with for the past couple of years, it's time to start showing companies that they can find real value in blockchain technology. So that's all for me today.